Okay, lights on. Thank you. So we'll get started here. My name is Hansang, and I'm the CTO for Riverbed. So for those of you that don't know Riverbed, we are a billion-dollar company, annual, and we like to say to ourselves, we're a billion-dollar startup. So we get the benefit of being agile as a startup company with a startup mentality, but we also have $1 billion of revenue to back us up. So we get kind of the best of both worlds. And I'm going to talk to you guys today about software-defined WAN. So I did a quick survey before some of you joined. It looks like for the most part, SD-WAN, software-defined WAN, hasn't really caught on. It's not a big thing here. In the US right now, it's about as hot as buzzword as there is. Everybody's jumping on SD-WAN. And so what is software-defined WAN? Ultimately, all it is automation and agility. Okay, and I'll go about how we accomplish that, why agility matters nowadays especially. And for those of you that don't know, this is what Riverbed has been doing for the last 10 years. Okay, some of you use Riverbed, some of you know Riverbed. So let me just kind of, everywhere you see an orange is where we accelerate traffic. What does that mean? It means when I use SharePoint Online and Office 365 and browsing the web, it can be 10 to 50 times faster than without Riverbed, or Steelhead, I should say. Okay, that's our what we call the WAN optimization. So you'll notice here a couple things, right? Everybody understands that there's a data center, primary, secondary, hot, etc., and you have branch offices. And this is where most of us sit. We don't, for the most part, go to a data center to work there, unless you're racking and stacking and running cables. Other than that, everybody works from a remote location or home office, etc. So from the branch location that you see here, you go to data centers, and now, more often than not, you're going to the cloud. Office 365, you're going to Azure, you're going to AWS. Okay, more and more companies are putting their data out in the cloud. So what's important about that? The important thing is latency. Okay? It's one thing if you own the data center, you own the MPLS circuit, you own the routers, and you own the branch. At least you have a shot at troubleshooting when things go slow, etc. Okay? When things are out there in the cloud, it's a different problem altogether. Okay? And software-defined WAN helps you with that scenario, and we'll see why in just a second. So it's important to note that not only do we make the wide area network or cloud feel faster, okay, makes the application run faster, but we give you proof. We can tell you the user experience from the cloud without any doubt whatsoever. Okay, so it's one thing to accelerate to the cloud. It's another thing to prove why it's slow, why the end user experience wasn't so good. Okay, so why does end user experience matter? It matters because right now, in the world that we're living in, we're going through some historic changes. This is New Zealand, an earthquake that caused this train rail to bend. Christchurch, I think it was. So if you think about the amount of force required, not to bend that steel, but that the rail bent because the earth moved. Think about the power. I don't know, anybody here experienced an earthquake personally? Yeah, one? I've been in 3 of them. And it's amazing to feel the ground, like you can feel the rolling wave and the entire apartment complex shaking. It's a phenomenal amount of force. So it's both thrilling, exciting, but fascinating that there's that much force, right? So think about the force that's required to move, not only bend that steel, okay, but it's also what's called an I-frame. It's made to be strong, the rail, the design. And the amount of earth that was moving. So right now, in every aspect of our life, social, philosophical, religion, politics, you name it, we're under and going through tectonic shifts. Everything that we know about technology is changing. And it's changing because of these things right here. Social media, good, bad, or otherwise. I can tell you, I spent 13 years as one of 6 global engineering leads at Citigroup, Citibank, Citi. And companies, like banks, are freaked out about social media. Companies like Samsung that make TV, that's probably in this room, are freaked out about social media. If you don't believe me, next time you buy something and you don't like something about it, tweet or put a Facebook post about it and have your friends like it, retweet it, etc. You know what's going to happen? Somebody's going to call you. So a friend of mine took my advice. He didn't like something about the TV and he complained on Facebook. And he called everybody and said, hey, come and like this. Next thing you know, somebody from Samsung called and said, we're sorry about your experience. We're going to upgrade you to the next model that doesn't have that limitation for free. Why? Because it's social media. Okay? So the problem with social media is there's good and the bad of social media. I call it drive-by shooting or drive-by social media. So you probably haven't heard about this. This was pretty famous in the United States. This is a baseball game. They call it America's pastime. And this is Arizona Diamondbacks. It's a baseball game. Okay? And baseball is probably not that popular here, but it's pretty popular in the United States. And the Fox News, or the Fox station, and the announcers excoriated these women. They made so much fun of these girls, and you can see some of the quotes. And some of them were funny. I watched this game, and I laughed. And especially when they said, this is the best one of the 300 pictures that I took today. Okay, I have nieces that do this, and so I get it, and I laughed. They were ashamed because everybody started retweeting and reposting saying, this is what's wrong. They're at a game. They're not paying attention. They're self-absorbed. They only care about themselves. The millennials, they don't care about what's going on. They're not even talking to one another. They're just taking selfies and tweeting and etc. And everybody laughed and made headline news. What you don't know is that every one of these girls, college girls here, freshmen and sophomores, are on a scholarship, meaning they're smart. Half of them are on the dean's list, which means they get their GPAs better than 3.5. So these are exceptional women, but they were shamed on national TV because of social media. So that's the dark side. So why do I bring that up? Because from a business, I did some research. This is one of the sample of the top 10 biggest lawsuits in the history. And I didn't know about the tobacco one. I mean, I knew the tobacco lawsuit in the United States. I didn't know it was $206 billion that they collectively had to pay. Okay, so look at those numbers. $7.2 billion in Enron. Nortel used to be one of, a very common name in the infrastructure world. $2.4 billion that they had to pay. I bring this up because all of these examples used to take an army of lawyers. As an end user, if something was wrong with my Lenovo laptop or ThinkPad, there was really nothing I could do about it. Now I can with social media, which means it's a class action lawsuit of one person. And I was just talking to a reporter who said it's the weapon of mass destruction by one person. One person makes a funny tweet, and the whole company philosophy can change. It's already happening. It's already happened. Sony, Bank of America, Toyota, they're all changing how they do business because of social media. And for those of you in infrastructure, if you don't pay attention to your end user experience, you can end up as an end of a funny end, the butt end, as we say, of a social media tweet. Okay? So it doesn't matter how much money you spend. Those of you in infrastructure, those of you in application development, those of you working at help desk, desktop client, doesn't matter. If your users are complaining, you've accomplished nothing. And SD-WAN says, I'll fix that for you. So let's talk about some of the way. Okay? And again, this is another way of saying network, of course it matters. Application, of course it matters. Design, architecture, yes it matters. But if your application is not performing, nothing else matters. Ask airlines like JetBlue that had to stop processing customers and flights because the application didn't work. Think about banks. And I'll give you an example. And actually, there's a demonstration unit right there for Oculus Rift, the VR. And everybody's heard of that, right? The virtual reality goggle that Facebook bought for $1 billion with a B. So I have that at home, the development kit. And when they finally released the consumer version, pre-order, I was online trying to order, and it wouldn't go through. I tried for 30 minutes to order the $600 Oculus Rift. I never worked so hard to spend $600 in my life. I was clicking and clicking and clicking and going, damn it, why isn't this working? And I ended up with like $61 charges, because every time you click, it checks to see if the credit card is good, and it charges $1 and then returns that $1. Okay? Why did that happen? Because the Oculus Rift people didn't anticipate the load, and they weren't sized properly. So in an ideal world, the server's cloud-based workflow replicates itself. Another instance comes online to handle the load. Another instance comes online to handle the load. Okay? Anybody here play Microsoft Halo? Yep, most. So when I talk to the Microsoft architects, when the first popular game releases, Xbox, internet-facing, they increase the capacity by a factor of 10 for the launch, for just 1 week. Because by 1 week, most gamers have finished the game, and people around the world have stopped playing non-stop 7x24. So they designed to the peak, right? And then after 1 week, when everybody's kind of done with the game or they play intermittently, they bring it back down to a factor of 10. That's what SD-WAN allows you to do. Design to peak. Now think about that. If you design to peak in your everyday life, in your network, you'd go out of business, because you'd have so much capacity at all other times that you'd go out of business having that much capacity. But Oculus Rift people didn't size it properly, and they lost a lot of business. They have a lot of frustrated users who made fun of them, not even being able to order the stupid thing. Okay? If they followed the cloud mentality, they would have anticipated, but more importantly, they would have made a change during the most critical time when people are ordering. Okay? So I'll give you an example of SD-WAN in just a second and why that Oculus Rift matters. The problem is this. Everything is getting more complex. Yes, it's getting easier. I can just say, okay, Google, and next thing you know, this phone's going to answer, and I can search for any fact in the world. Okay? That's the time and the world that we live in. Anything is at fingertips, and we want it fast. Anybody, I don't know if C.K. Lewis, a comedian, is, anybody here heard of C.K. Lewis? 1, 2. Well, that's good, because I'm going to tell his joke, and I can take credit for it. C.K. Lewis is sitting on an airplane, sitting next to a guy who's using his laptop, Wi-Fi. And something slows down. Clearly not a customer of Riverbed, because if they had a Riverbed on the plane, it would be fast. And he looks at C.K. Lewis, the comedian, and goes, can you believe this? It's like, it doesn't even work. It's so slow. And the comedian, C.K. Lewis, wanted to tell him, the signal for your Wi-Fi is coming from space. It's a satellite. It's going out to space and coming back down to Earth. Give it a second. And he said, you're sitting in a magical chair, flying 600 miles an hour, 30,000 feet in the air, and you're flying in air. That's what you are, in a magical chair. And you're complaining about a few seconds of delay. But that's the world we live in. Once you've had good Wi-Fi, there's no back. Okay? And I can tell you for a fact that there's a major hotel chain in the United States that's spending tremendous amount of money improving their hotel. How? Better shower? Nope. Better linen, Egyptian cotton? Nope. Better pillow? Nope. More comfortable bed? Nope. Bigger rooms? No. Better TV? No. Wi-Fi. what they're finding is that younger people, especially, and I'm one of those too, not younger, but technology guy, doesn't matter about the hotel. Once the Wi-Fi is slow, their Yelp review is, it sucks. They could be in the lavish, best hotel room in the world. If Wi-Fi sucks, they give it a 1-star rating and they're losing business. Okay? That's the world we live in, and things are getting harder and harder. So SD-WAN, that's what the session's about, the promise. What does it do? Is it another technology looking for an answer? It's not. It's actually a game changer if you do it right. So let's talk about what that says. Any electrical engineers in the audience? Okay. So you should know that the middle symbol there is an exclusive OR gate. This is what computers are built out of. Okay, it's called an XOR gate. Essentially, and that on what you see on your left is a Boolean logic symbol called exclusive OR, the truth table to the right. Exclusive OR means you can have A or you can have B. Okay? But you can't have both. So in the United States, there's a saying called, you can't have your cake and eat it too. You can have your cake, but if you have it, you can't eat it. You're making a compromise. That's what exclusive OR says. You can have one, but not the other. So what do we do? What compromises do we make as infrastructure people? I want everything that's on the left, and I want everything that's on the right, but I can't. So I'll choose one or the other. I want that local performance. I want the data local to me, but I can't because I have to centralize everything for data protection. I make a compromise. Okay? Who doesn't want that SaaS agility? Change a bookmark and everybody gets a new version of Office 365. Who doesn't want to sign up for that? The problem is I'm afraid because I'm going to lose visibility. Okay? So let's take a look at these and say, what if? What if you can have both? Okay? This isn't that Morpheus giving that red pill, blue pill. You guys are in technology. You should know exactly what I'm talking about. Okay? It's not a choice. You don't have to make a choice. You can have both. SD-WAN says you can have both. I'll give you a perfect example. Here's a screenshot, one of our UI. And I can tell you for a fact that a customer purchased our equipment for this checkbox right here. Okay? And all of this is saying is, if I'm using the internet as a transport, encrypt it. That's what this UI is saying. I want to send traffic through the internet, make sure it's encrypted. Okay? So those of you that are familiar, on the router side, this is what you have to do. This is the equivalent IPsec configuration that you have to get right at every site. And if you make a mistake, two things are going to happen. If you make a mistake, the best case scenario is you black hole that traffic. That's the best case scenario. The worst case scenario is you're going to send traffic on the internet, maybe not encrypted. Okay? That's what we call a self-correcting mistake. You make that mistake once, you're fired, you're not going to make that mistake again. Okay? Because your company's intellectual property, or God forbid, you'll be sued for lack of privacy. If I were doing this session a year and a half, 2 years ago, I would make a joke about Snowden saying, don't worry, the US government is backing up your data. Okay? You'll get that joke in a second. Don't worry about it. So, you can either do this, contend with this complexity, or do this. Which one do you want? I want both. I want the simplicity, and I want the security of without the complexity. Okay? So, let's take a look at some of the other examples. This is what everybody's racing towards. I want to use the internet to go to the SaaS services. I want to use the internet as a transport to go to my data center. More and more, my applications are sitting out here. ServiceNow, SaaS, etc. Okay? There's a pros and cons to this because in reality, this is the price that you pay. Okay? So everything that's green is good. Direct to internet makes sense, but it's less secure. It is. It's the internet. Lower quality. You're buying a cheaper circuit because the service level agreement is weaker. That's the bottom line. That's why internet pipes are cheaper, because the carriers don't have to give you that 5 nines or 4 nines worth of uptime, and performance. Okay? MPLS is great, but problem is, yes, it's more secure in theory. It's higher quality in theory, and you pay for it. The problem is you have to backhaul traffic to go out to the internet. If you're going to SaaS and you have an internet connection at the branch, why not go direct? Why boomerang them all the way back to the data center to go back out? Because you want control. That's why. You're making a compromise. Okay? Well, it turns out with Riverbed, you don't have to make that compromise. So let's look at some of these examples. FM Logistics. They're a customer of ours. He was nice enough to come with me to Open Network User Group in New York, and he presented his business case. What this is telling you, okay, especially with the Statoil and all the oil stuff that's happening to your economy and to the US, your job is to save money for your company and look like a hero. If you save money and provide better service, you'll look like a hero. You'll get a bigger bonus. That's how it works in this world. And that's what FM Logistics did. So before using us, they had to use MPLS, like everybody else. But it cost money. After, you remember that checkbox, secure internet? After using us, they were able to transfer almost all of their traffic to internet. Because it's easy and it's secure. They don't have to worry about the complexity. So what happened? The budget for infrastructure went down. He was able to save money, looked like a hero. Here's another company that every week save about 1/4 petabyte a week. 228 terabytes a week disappears because of WAN optimization. So in 1 month, that's a petabyte. Anybody know how much a petabyte is? It's a big number, a lot of zeros. You all have DVRs, right? And movies that you watch. A petabyte is equivalent to 13 years worth of high definition streaming. If you take a movie that's 13 years long and you capture it to disk, that's a petabyte. That's how much data disappears from this company because of our product. Okay? So, I'll give you some examples in just a second. Let me kind of recap how we can help you. We monitor every click of a browser. That's what we do. When you click on a browser, we can tell you how long it took and why it took that long, including SaaS. Every packet, every flow is accounted for. People talk about big data, and those of you that have been in infrastructure know this. If you account for every packet flying around your network and you want to make sense of it, that's big data analysis. Okay? So don't let these database guys that talk about petabytes and table size that's 100,000 rows, etc., scare you off. Think about how many packets are flying around your network right now. Think about the number of packets flying around the internet right now. If that's not big data, I don't know what is. We make sense of that. And then most importantly, we make sense of the application itself. Why is that application slow? We can tell you, and I'll show you some examples in just a second. Okay? So we don't care if you're coming through the cloud, you have a physical data center or a software-defined data center. I don't care if you have an application with this many layers. Okay? And some of you may have heard my joke, but this application right here, web, app, and database, this application, anybody know the name of this application? Every one of you right now run this application at work. And it's called TTMA. And you're thinking, I don't have an application called TTMA. I guarantee you do. Okay? TTMA stands for 3-tier my ass. This whole web, app, database, 3-tier, nice and clean, that only exists on paper. You have multiple data centers, multiple redundancy. You have load balancers front-ending an army of web servers that talk to an army of middleware servers that talk to 2 big data center databases. That's why it's called 3-tier my ass. Okay? And then it's coming now to add to that complexity. You can use internet as a transport that you have no control over, or use a tried and true MPLS, but you're going to pay more. You have users sitting with Surface Pro right there, probably one of the biggest kept secret of Microsoft, Surface Pro. and users sitting in campus locations. Okay? This is what you're faced with. This is what you're expected to work all the time, 100% time. I can guarantee you that none of you guys ever got a phone call that said, hey, thanks, the network was up. The only phone calls you ever get is when it's down. Okay? And this is the problem. We live in a world where we expect everything to happen sub-second, every piece of information at a fingertip, and when it stops, all hell breaks loose. And you think, yeah, I know those end users, pain them in the ass, always giving me grief. What happened the last time you turned on your faucet and the water didn't come out? All hell breaks loose. You can't flush your toilet, you can't take a shower, can't brush your teeth. I've been through that. I was in New York when Storm Sandy hit. Manhattan was underwater. I could not get gas for a week. I waited 6 hours to get $10 worth of gas. 6 hours standing in line to get gasoline because trucks couldn't come in because of Sandy. We had a friend of mine who didn't have power for 10 days. He threw out everything in his refrigerator because they all went bad. Okay? It was chaos. And this is New York City. So when something that you expect to happen stops for even just a few minutes, all hell breaks loose. So if your application, your network, your end users can't do business, all hell breaks loose. So let's talk about these examples, the choices that we're making because we don't have SD-WAN. Go back. Performance and centralized data. I talked about this. I want that local performance. If it's on my SSD, if it's on my hard drive, it is faster. I don't care what anybody says. But I can't have distributed data because people can walk off with laptops. You can lose data. It's hard to back up data if everybody's running around with a copy of the database. So you centralize it. So we have a technology that allows you to do both. And we call it zero branch IT. You can talk to my colleagues that are sitting in the room with a booth out there if you want to find out more about it. Essentially what it is a smartphone approach to technology. When you upgraded your phone last time, did you have to get a tape backup software to replicate your application? Some of you are laughing. Some of you are like, tape backup, what the hell is that? Do you know that when I started in technology, we had a job title called Tape Boy or Tape Girl? And the newest member of the team was called Tape Boy because it's a pain in the ass. You have to go down to the data center, take out the carousel of tapes, switch them all out, label them, put it back in, and hope it works. Okay? And I had a thing about every day I would make the Tape Boy or Tape Girl pick out a random tape and recover one file. Because I told them, if your job's on the line, if this is your business critical data and you've never recovered, when you put that tape in, you're hoping and praying, please God, let this tape be, let it A, be backed up properly, and B, it's readable. Okay, most people, they back it up. They back it up every day, and they never check the tape. So anyway, it's a bad job, so we called him Tape Boy. So the last time I upgraded my phone, which is like every year, because I love technology, they didn't give me a tape backup to recover my text, contact, etc. When I walked out of the store, everything was recovered. That's what we do with our technology called SteelFusion. So let me give you a quick technical representation of what it means. I have my data center. I have my remote fusion box out here. Essentially, we do a couple of different magics, okay? And those are all technical terms. The important thing is that you take your disk that's in the data center and you project it out to the remote location. The data is local, but it's not really local because it's being projected. And for you Citrix and VDI people, we finally finished what VMware started. Give credit where credit is due. Yes, now we have Hyper-V. Yes, we have Linux containers. But it was really VMware that said you can share your server. Because before VMware came around, every app guy said, my app, my server, no one else can use it, even though I'm only using 3% of the CPU. Okay? So why are we completing what VMware started? because we allow you to separate compute and storage. So those of you that are involved in VDI, you know that you cannot separate compute and storage. They have to be sitting side by side. Our technology allows you to separate, finish what VMware started, what virtualization promised. Meaning, I can put this image out at the remote location, get that local performance, and yet everything is still centralized. If it sounds like magic, it kind of is. And you won't believe it until you try it. Okay? And the other piece is, of course, you get the WAN optimization so your applications run faster regardless. Okay, this is what Fusion does. All right. Oh, by the way, the easiest way to think about Fusion is, because this is kind of complicated graphics, think about the rack in the data center. The rack of servers, routers, and switches, and database and middleware, the TTMA. On demand, extend that rack out to the remote location, let them use it, enjoy it, snap it back. Which means you can recover in minutes, not days or weeks. Okay? We have a government. How much time do I have? I have time. We have a US government whose standard operating procedure is this, because it's highly sensitive data. Every morning, somebody comes into a location, and they go down to the vault, open the vault, they take out all these drives, hard drives, and then they stick it into all the servers and blade servers, etc. Okay? And then people come to work, and at night, when everybody's done, they take all the drives out and they put it into the vault. Why? Because it's highly sensitive, and they can't afford to lose it. They're changing from that to Fusion. Why? Because the data in harm's way doesn't have to be there. Yes, it's local, but it's being replicated magically to the common data center. Okay? So think about that. It's a game-changing technology that allows you to keep the data local, but yet centralized with no performance benefits or degradation. The next one, SaaS. How many of you use Office 365? Okay, quite a few of you. Right? How many of you are thinking of SaaS? A SaaS service, whether it's payroll, CRM, HR, ServiceNow. Anybody use ServiceNow on the infrastructure side? That's SaaS. Office 365 is SaaS, obviously. I want that agility, but I'm afraid of losing visibility. So let me show you how we do it. A, at the branch location that you see to your left, when you go to a SaaS, no matter where that SaaS data center is, okay? The thing about the cloud, ladies and gentlemen, it doesn't really just float around forever out there. It's not a real cloud. People asked me that one time, hey, where is the cloud? Is it just like a plane of data centers floating around? I said, no. There's about 16 of them in the world. It's in Amsterdam, it's in Ireland, it's in Singapore, it's in Hong Kong, it's in Virginia, it's in Las Vegas, it's in San Jose, and that's about it. The secret about the dirty little secret about the SaaS is that just about everybody uses the same locations for the data centers, for their cloud hosting. So what do? We go from the branch. This is a box that you own. We auto-magically boot up a Steelhead in the cloud and drop you off into Microsoft World or SaaS, Salesforce, Workday, etc. Okay? So which means that we bypass the uncertainty of the internet. We accelerate the traffic from your branch all the way to the doorstep of where Microsoft's data center is. And it's accelerated. It's faster. But more importantly, we get telemetry from it. And these are all the SaaS applications that we support, more coming. Okay? And if you notice, Box, ServiceNow, Office 365, this is an HR company, etc. Okay? And again, we get telemetry from it. So let me show you what that telemetry looks like. This is the end user experience. For some reason in India, life sucks. That's not a political, philosophical statement. I'm just saying, from an end user, it sucks. Okay? And if you're the CIO, remember that TTMA, 3-tier my ass application? And you're thinking, phew, I offloaded it to SaaS. The problem is that TTMA, 3-tier my ass, became my app my ass. My SAS, my ass. If the SAS experience is no good, you're fired. You or your replacement will get the SAS deployment properly. Okay? So now we can make sense of what that SAS experience is like. We can tell you this is an HTTP waterfall diagram for a SAS application. I can give you individual transaction and why it was slow. As if that's not enough, I color-coded it for you. Well, I didn't. Our engineers did. If it's that pink color, it's a server delay. If it's that green color, it's a network delay. No question why it was slow. And then you can keep tabs on it with a heat map. SD-WAN is about networking and BGP. For those of you that are in infrastructure, BGP is important. This is a view that talks about how your BGP, your AS traffic movement looks like. How much data is going outbound and inbound from your organization. It's complicated. We make it simple with a graph like this. And then with a few clicks, I can tell you who that is, including voice. And using our technology that I'll talk about in a second, if users are trying to tunnel BitTorrent, we don't count on IP addresses. We don't care about IP addresses and port numbers. We use what's called deep packet inspection to look inside. So if you think you're being smart and you're using BitTorrent and your company uses us, stop. Okay? Because we can find you and, well, unless BitTorrent is your business. So this is the level of visibility that you get. Here's one for NSX. If you're a VMware shop, NSX, we make sense of how much traffic is within the machine and outside of that ESX hypervisor. Information that you need to know. And we tell you what's inside those hypervisor VXLAN tunnels. Okay? Again, we look deep inside. We care about the application. We don't care about the IP address. And we really should have a funeral for the IP address. Okay? And we did at a technical training. Do you really care what Microsoft's address is? Because if you're working on routers, the only mechanism you have is IP addresses. How many of you wrote an access list before on a Cisco router? What did you use? IP address, TCP port numbers. That's all you had. So now what are you going to do? If you're trying to triage or take care of Microsoft software, what do? You try to put every Microsoft IP address in there? That's not going to work. Okay? We don't care about IP addresses because we care about applications. We at Riverbed, we don't route packets, we route application. Yes, it's a good tagline, rather proud of it, but it's fundamentally different way of thinking about it. We care about applications, not packets, and so should you. And that's what SD-WAN allows you to do, okay? And when you do that, you can get a dependency diagram at the hypervisor level, not at the packet level. They're both important, but this is important as well, because this is application, how your application is talking. Then we make sense of Link and Skype. If you ever had to deal with voice over IP issues, I feel bad for you because it's a tough problem. It's very challenging. The whole world is against you if you're monitoring voice. And we make sense of it from who called whom, where they called from, what their experience was like, what path they took, and then we tell you other environmental factors like everybody that's coming into Wi-Fi, via Wi-Fi, not so good. The problem is Wi-Fi, not VoIP. So stop your troubleshooting. We pinpointed the problem for you. Okay, this is what I mean about visibility. And then we don't stop there. We go all the way to the application. Here's an application level dependency mapping. This alone is worth its weight in gold. When you're troubleshooting why something is slow, you have to know what your enemy looks like, what servers and processes are involved. And that's what we do, give you visual representation of that. And then with a single 1 or 2 clicks, we can tell you why that process was slow. If I'm an app developer, I'm going to go attack this blue bar here because it's the longest one. Took the most amount of time. Okay? The next one is about elasticity that I talked about with Xbox, using Internet as a WAN without complex routing. Okay? So let's look at some of these examples. This is what Riverbed SD-WAN does in a nutshell. I'm going to go over these real quick. WAN optimization. We defeat the speed of light. We make things go faster than the speed of light. Effectively, that's what we do. Okay? Application intelligence. This is that deep packet inspection that I spoke about. I can tell the difference between social media. Okay, I don't use IP addresses to make a determination about Facebook or Twitter, etc. Okay? I use deep packet inspection. So even if you try to tunnel it, I can find you. Path selection is nothing more than go left, go right. Use internet for net backup. Use MPLS for voice. It sounds simple, but if you ever had to configure a router, it's a difficult proposition. We make it simple. Quality of service? Horrible. Anybody here deal with quality of service issues? Anybody responsible for QoS? It sucks. It's a fundamentally broken technology. Okay? Everything is against you. We help because we can give you hop by hop quality of service measurements, etc. So anyway, it's just take it up my word that it's hard to do. We make it easier. Secure transport, we talked about. We can encrypt on demand, only for the traffic that we care about. Web proxy. So web proxy is something new. It's back to the future for us. Proxy is something that we all dealt with in the 90s. For the most part, a lot of you probably don't use proxies as much anymore. But we now had to bring up proxies for this reason, video. There's a reason why it's called a viral video. There's a reason why YouTube is #1 consumer of bandwidth on the internet. Because it's funny, it's timely. Last night I was watching YouTube videos. That takes bandwidth. It's also something that I can't optimize because I don't have a steelhead in YouTube land. But I do have a proxy. Every steelhead that you buy now comes with a proxy, which means you can cache video, which means you can have a town hall video conferencing without breaking the budget for bandwidth. Why? Because we can take that one stream of video and send that out to everybody at the branch location. This is what multicast is supposed to do, but a lot of us don't have the wherewithal to deploy multicast. We take care of it for you. Okay? And then, of course, we cache internet videos. The other one, SSL. SSL is the new TCP. So all of you know about TCP/IP, right? The stack, TCP, right? TCP is dead because everything is encrypted nowadays. SSL is the new norm. Everything is tunneled or uses SSL pretty much. We have patented way of ensuring that yes, it's encrypted, but we can look inside so we can report on that experience. This is how I can tell you why your Office 365 experience was good, bad, or otherwise without compromising security. Okay, so this is a key thing. And if any vendor comes to you and says, hey, let me have your private certificate so I can put it out at the branch so I can help you, what should you do? Kick them out. Because what they just did was compromise your entire company's intellectual property by putting a certificate out at the branch location. Okay? We don't do that. So again, it's a patented way of dealing with security. The last one. This is my favorite. Because A, I'm an infrastructure guy. I've been doing routing and switching a long time. Dynamic routing versus change control. Why do I talk about this? Everybody in the internet or working in the networking, we talk about millisecond failure rate, our OSPF, BGP, EIGRP, RIP, if you're still using RIP. We talk about sub-second, right? Failovers, it's dynamic. How many of you have been on a troubleshooting call where someone from the network said, I can ping you just fine, it's not my problem. And end users can't log in, right? You got people like me at Oculus going, buy, and I can't buy. All right? It impacts the bottom line. Because network guys talk about dynamic routing. But we have this thing called change control. Why do we have change control? Because people make mistakes. During Christmas and Thanksgiving in the United States, there's a thing called change control freeze. You can't make a change because when you make changes, things break. Okay? This is why technology people hate Mondays. Because what happens over the weekend? Changes. Do you know that at Citigroup, we tallied this once, I ran a report. At Citigroup, just from a networking side, there were 23,000 changes a year. I ran a report in change control system. 23,000 network-related changes a year, because we had 20 to 40,000 routers and switches in our network. That's a lot. And almost 95% of the outage was caused by someone forgetting a line, making an on-the-fly change, and this is why there's change control freeze. Okay? Make sense? Because if you don't change things, things tend not to break. But think about that Oculus Rift example. When that Oculus Rift network guy or the application guy saw this tremendous demand, wouldn't it be nice if he could say, provision another 10 gig to my redundant data center, bring up another server to handle the load? But they can't, because it's the most critical time, and they rather sit out and not make a change and suffer through that problem than make a dynamic change. Our SD-WAN at Riverbed will make that change for you without making a mistake. When we realize that you're under duress, when there's too much traffic for your critical and important application, we'll make that change on your behalf so that your business can get back to doing their business and not worry about retransmissions. Do you really think your heads of business that you guys are in, your CIO, cares about retransmission? Of course not. He just wants to get business done. And your job is to make that happen. We're going to arm you with a weapon needed to do that. So, how do we do that? Another cool picture. We had a picture of a lion there, but then he was shot by a dentist, so we changed it to a tiger. No, I'm just kidding. You'll get that on your way home. You'll get that joke on your way home. So, this is not Cecil, but it's a cool tiger, and we have a project coming called Project Tiger. It's actually, you can buy this now in a smaller form factor, and the bigger one's coming later this year. What does it do? It solves this problem. At the remote location, you have a router. I guarantee you do, because you need it. That's how the internet works. But if you have a device that can give you encryption, click of a button, that can monitor every packet for quality of service issues, that can understand the application at the application level, not IP address, that can make things go faster, that can rate limit. Do I really need a router out there anymore? Probably not. So, this is what we're building right now. So let me orient you to this screen, and I'm almost done. Each one of these columns is a Linux container, meaning they're firewalled from one another. So the routing process runs in its own Linux container. Path selection, the go left, go right, runs its own container. Packet capture, the passion of my life. Those of you that don't know, one of the things that I love is Wireshark. I teach Wireshark. I do packet analysis. Some of you I recognize from my previous sessions. And third-party service means if you want to have a Palo Alto firewall, boot one up, because our Linux container will host it for you. This is a fundamentally different way of tackling your branch problem. Okay? And there's a thing that's called Network Services Header, NSH, that allows you to start chaining these services. We will intelligently put a marker on your application that says, hey, you're going to the internet, I want you to go through the firewall. You're going through the MPLS, you don't have to go through the firewall. Okay, everybody has a list of ticket or a checkpoint where they need to stop and get off. Okay, it's like having your own private train, subway, carpool lane. And that's what Network Services Header allows you to do. Okay, does that make sense? Let me show it to you visually. I have a branch, and I have 3 different networks I can choose from. MPLS, cost money. I have internet as a transport. And maybe I'm important enough and I have a tertiary 4G satellite or 4G backup. Okay, I have a choice between the 3. The problem with LTE is you get charged by utilization. It's pay as you go. So I don't really want to use it all the time, but I do want to use it in case of a failure. Okay? So what do we do? What does SD-WAN says? What is the promise of SD-WAN? The application now tells a network, hell no, I'm not going that way because your lane sucks. I'm a VIP. I'm going this way. And the network and the routers can't do a damn thing about it. The application finally dictates its will on every router and says, I'm not going this way, I'm going this way. Every application that's important gets its own lane, gets the premium VIP experience. How do we do that? We know where the users are sitting. We know how much bandwidth they're consuming. We know what their performance is like, and we can make the application run faster. If you can do that, and you can do it in a programmatic way, your life will be better. You won't get that call 2 o'clock in the morning because something went wrong. You won't get the call because your customers can't buy the product that you're selling. Your oil rigs will continue to drill because something didn't go wrong. Okay? And if you run out of capacity, SD-WAN will take advantage of the intelligence, of the analytics that's available, bring it all and mix it all in, and make that beautiful cake so you can have it and eat it too. Okay? Make sense? So if you haven't researched SD-WAN, highly recommend that you do. You can talk to us at the booth, because if this is what you want to do, okay, SD-WAN is the promise. And you're thinking, yeah, bullshit. It's not being recorded, right? So I can, sorry. Baloney. It doesn't work. It does. It works because it's automated, because people are not involved. Okay? If Tesla and Google can make cars that are self-driving, we can certainly make a device that can identify an application and give it a premium experience. We've been doing it 10 years. We just didn't know to call it SD-WAN. Okay, with that, thank you very much. I hope you enjoy the rest of the conference. And I think there were a couple of questions on the Wireshark. Happy to answer. Or if you have any questions about what SD-WAN is supposed to do, how we can help you, by all means, stop by our booth, and we'll go into it in depth. Okay? All right, thank you, folks.